Alright, welcome back. So we're going to do another video on this. Still a really good chance I can take the test. Last time I checked, unfortunately it was still only available to Juniper employees. But I am learning a lot about networking by doing this, and I am a network engineer, so this is going to be a good thing to continue doing. So let's continue doing it. Okay, so we're going to need to go into the folder I was using, and I wish I had, I wish all of this were in my other Google Drive. I don't know how to move folders to different Google Drives. And I don't know why there's a... Oh, no, that was there before. Okay, so we're doing... oh, the order got messed up. Okay, but now the order is correct. So we're doing MPLS. We're doing... oh, the order is messed up here as well. Okay, so we're doing... not done. We're not done with traffic engineering. Order's messed up. Okay, so this is where we were at. Let's start off by seeing if I uploaded the last video. Things are just too crazy for me to remember that right now. So we did, yep, and we were reading through an article because I really couldn't find enough really good information about it, and there were gaps in my knowledge that I wanted to fill in by reading that article. So let's continue reading that article, and it's going to be a two-part article, so it might be pretty long. So let's get started. Okay, so here's part one. So this is the section we'll be reading right now. Oh, unless it's oh, so these might be out of order. Yeah, so they were out of order. All right, so let's make the title and stuff. Okay, and we don't know what the next video is going to be now, so we'll blank this out for now. So, okay, cool. But what is INET.3 exactly used for? So now our router 1, and I do consider this to be our router, this guy knows... See, I dived into this thinking it was going to be like the Juniper documentation. I forgot it was written by this guy. Knows about a label switch path to the IP address 3.3.3.3. This means that if I were to ping 3.3.3.3 from router 1, the outgoing packet would have a label attached to it, right? The traffic would go down the label switch path, right? Right? Well, no, not quite. You see, in Junos, the INET.3 table has one very specific job: to resolve BGP next hops. Here's the key thing to understand. Whenever a Juniper router learns a route by BGP, it will first try to resolve the BGP next hop in the INET.3 table. It doesn't matter if there isn't a match in INET.3. Our beautiful router falls back to the INET.0 table instead, but by default it looks in the INET.3 first. In other words, traffic destined to 3.3.3.3 will not take the label switch path. In fact, it will just go out of the router as a regular packet. But if there's a prefix in the regular inet.0 path learned via BGP, and if the BGP next hop is in the inet.3 table, then that will take the label switch path. Just in case you don't quite understand, let's look at an example. Once again, in our diagram, R1 is learning about the 69.69.69.0/24 network. Nice, I thought he would leave that out this time. By BGP from R3 first. Remember what happened earlier with no MPLS? Router 1 receives a network destined to 69.69.69.69, nice. R1 looks in inet.0 and sees it has a match for the 69.69.69.0/24 network, nice. Learned from 3.3.3.3. R1 then does a second lookup and discovers that it can get to 3.3.3.3 via 10.10.12.2. R1 then pushes the packet out as a normal IP packet. Now let's run the same scenario, but with MPLS turned on. Router 1 once again looks up 69.69.69.0/24, nice, and sees that it's learned about this prefix via BGP from 3.3.3.3. But this time, Router 1 knows that it actually has a label switch path to 3.3.3.3. It knows this because it looked in inet.3. So R1 sends the packet out, but this time with a label saying that it's destined to 3.3.3.3. We can see this label by looking the extensive output for the route. So here's the label operation. It's pushing a label. So where did this label 299.904 come from? Well, R2 actually told R1 that this is the label it wants to receive. And to know what R2 does with this label, we introduce the other routing table of interest to us, MPLS.0. The MPLS.0 and inet.3 tables have similar but distinct tasks. In inet.3, you're going to find all the LSPs for which this router is acting as the ingress. In other words, the start of the tunnel. Thank you, Chris, for introducing that explanation of ingress and egress in terms of LSPs to me. It really helped me understand it. I really was not understanding why it would be considered an ingress router. This is why BGP uses this table to resolve next hops. By contrast, our MPLS.0 table is used when we receive a packet that has a label on it already. In other words, think of MPLS.0 as the routing table for any LSPs where we're acting as a transit router, i.e. a router in the middle of an LSP. Let's have a look at what Router 2 does when it receives a packet with label 229.004. So it should swap it, right? Oh, it knows the name of the LSPs we configured on Router 1. That's the magic of RSVP, baby. If we were to look, so it didn't swap it. I'm not exactly sure what it did. If we were to look into the extensive output of this label, we would see that Router 2 will put on this packet as it sends the packet on its way. In fact, because the next hop is router 3, i.e. the final hop, we would see that the label is being popped because of penultimate hop popping. The packet is sent out unlabeled because the packet is being sent to its final destination. Fun bonus fact, S equals 0 refers to whether the bottom of stack bit has been set in the MPLS header. If S equals 1, the label is the bottom of the stack. If S equals 0, then there is one or more labels underneath this one. For example, this top label might tell the router where to forward traffic, whereas the bottom label might tell the egress router which MPLS VPN the packet belongs to. Why does only BGP use INET.3? Now you might be wondering, why is it only that BGP gets to use INET.3 to resolve next hops? What's so special? Oh my god. What's so special about BGP? Did it bribe its way into the LSP's heart? Did BGP's dad go to school with MPLS's dad? It's always who you know in this business, right, isn't it? Jesus. It might seem odd at first, especially after reading that Juniper documentation. It's just like, if it's not just completely dry, like it's got me. It's got me laughing. It might seem odd at first, but there's actually a few good reasons. The first is a simple one. OSPF and ISIS are getting their next hops from a router that's directly connected to it, so it doesn't need a label switch path. At this point in the post, let's say explicitly what I've so far just implied. The reason that Junos doesn't, by default, advertise labels for its physical interfaces and only advertises labels for its loopback is because BGP advertises the loopback as the next hop. And on the whole, we tend to only want to send traffic down label switched paths if the destination was learned by BGP. Another reason it's common in large ISPs to actually run a network with a BGP-free core. In other words, not every router will actually be running BGP. MPLS allows traffic to travel across a core network that is actually completely unaware of how to get to the IP address in the packet. Again, this won't be the case with OSPF and ISIS, which are protocols that will definitely be running throughout our network. A final example is MPLS VPNs, which are of course advertised by BGP. The labels are used to distinguish between two different customers who may even be using the same private IPs. In addition, the use of labels means that our core routers don't need to know anything about our VRFs. We can run layer 3 VPNs, layer 2 VPNs, VPLS, and so on, all running at the edge of the network with our core routers totally unaware. So most of the time, the INET.3 table is only needed by BGP. But of course, most of the time doesn't mean all the time. Wouldn't it be good if we could change this default behavior? Wouldn't that just be awesome and the best thing ever? Well, guess what? I've drunk 2 bottles of gin today. Okay? Also, guess what? Oh man, this guy, I'm concerned about this guy. Seems like he's an alcoholic. This doesn't look like an alcoholic drink, but seems like it might be an alcoholic. I guess, like, isn't there some law, like, when it comes to like serious alcoholism and like AA meetings and all that, you can't call someone an alcoholic unless you were an alcoholic at some point. I don't know. I'm not an alcoholic, so I don't know what's the deal with this guy. He does seem to know what he's talking about, and he un-effed my brain when it came to talking about a router with a from statement and a to statement being the ingress router for that LSP. I was having trouble thinking of it that way. I was thinking, oh, since it's the router with the from statement, it's going to be the egress. But no, it's a tunnel, and the tunnel's unidirectional, so you can only go in the tunnel this way, and you can only go out the tunnel this way. I think I hadn't fully grasped the meaning of unidirectionality when it comes to LSPs. I basically just memorized the concept, but I didn't intuitively grasp it. And the fact that it is unidirectional and that I now grasp that intuitively makes those terms ingress and egress much more makes sense to me. Those are the proper terms, because if you can only enter this way, your ingress is going to be here, and then your egress is going to be here. So the local router is going to be the ingress router. Also, guess what? There are many ways to change this default behavior, each with their own upsides and drawbacks. Some of these ways you'll use in the real world, and some of them are really just corner cases to fix specific occasional problems. And in part 2, we're going to talk about exactly that. Click here for part 2, where we learn how to totally change everything we've read about. We'll be moving things between inet.0 and inet.3 so much that you won't even know what planet you are on anymore. I kind of want to comment. I'm going to follow this guy on LinkedIn. Oh my god. Principal network architect. Good get, man. Connect. Add a note. Hi, Chris. I'm going for my JNCIE SP. I'm documenting all of my study on YouTube, and today's video is reading your blog. Thanks for the great info. Thanks for the great info you effed my brain when you on my brain when it came to understanding the terms ingress and egress. Ending LSPs and the terms ingress and egress. Okay, and then I will give him a link to my channel, and that will be that. So my channel's here, so let's see what my sharing link is. If I may, I have a feeling I may not. So let's maybe go to my studio. Maybe there's a sharing link there. No nope, there's no way to share my channel. So let's go back to my channel here. There we go. So I think this is a proper link. Let's use that. It might be, perfect. So I've got 6 characters left. So yep, this is gonna be good. Hi Chris, I'm going for my JNCIESP. I'm documenting all of my study on YouTube. Today's video is reading your blog. Thanks for the great info. You NF my brain when it came to understanding LSPs and the terms ingress and egress. Within the context of LSPs. Within the for LSPs. Done. Okay, so that's going to be a pretty solid connection, I think. So let's yeah, let's keep looking here. So so let's keep reading. So I finished this one, so let's click here for part 2 just to make sure it's the same. Yep, it's the same one. But okay, I'll close this, and yep, here we go. So moving LSPs between INET.3 and INET.0 on the Juniper router. This is a post about the different ways and reasons why we might move prefixes between the INET.3 and INET.0 tables on a Juniper router. You know, like George Clooney does in his, oh my god, spare time. Probably don't look that up. So George Clooney has been clean so far. I will say don't look up Ben Affleck. But certainly don't look up Harvey Weinstein or Bill Cosby. George Clooney, though, you can probably he's more likely to be studying Juniper routers in his spare time than most Hollywood celebrities, because as far as I know, he is clean in the headlines still. I could be very wrong about that though, and. This is probably going to really date this video over the next few years. If you're not sure what the INET.3 table actually is, then give part 1 of this post a read, where I explain how BGP uses it to resolve next hops. Don't worry, take your time reading it. I'll wait, no rush. I've got a nice cup of hot chocolate to drink. Check your carbs, man. There's a lot of sugar in there. You're back. So now you're curious. Is there a way to make other traffic go down an LSP besides BGP learned routes? And are there any unintended consequences of manipulating this behavior? The answer to those questions is yes and oh yes. In this post, we're going to take a deep dive into some of the different options available to us for transferring prefixes between INET.3 and INET.0. We'll see what happens when we put this into action. We'll talk about the side effects, and we'll even talk about what we can do to get around the problems we might have caused. Before we start, there's something you absolutely have to understand. Next Wednesday, I plan to be fully nude for 24 hours for charity. Please send me 100 pounds to support my brave, generous action. All profit will go to an organization that teaches dogs how to perform basic to intermediate level heart surgery. I'm not sure if I'm going to donate to that cause, and I really question if this is outside of his usual plans. It is good that it's for charity, because that's another thing I would question is if this were part of his usual plans, would it be for charity in that case? So it is nice to hear that in the case of next Wednesday, which This was 2 years ago. He did spend 24 hours nude for the purposes of charity. A little concerning that there might have been other instances where it wasn't for charity, but perhaps I am reading too far in between the lines. Override 1. Install a prefix into inet.3 and associate it with an RSVP LSP. Okay, and I'm not going to do this in my lab again. I don't know. It probably would help, but well, first of all, the purpose of this video is to learn about the oops, and it took it out of order again. Is to learn about the IGP/BGP knob, and this doesn't cover this at all. I was just so completely confused. I just wanted to learn more to get a better sense of things. Oh, and I'm gonna need to take a quick break. I'll be right back. All right, I'm back and feeling better. Let's do not that I paused the video because I needed to throw up or anything. I just needed a quick I ate a hamburger patty. Take a look at this beautiful topology. We actually used this in part 1. We have LDP everywhere, and in addition there's an RSVP LSP from R1 straight to R3, and another on R3 back to R1. You can see that R3 has an eBGP peering to R6, from which it's learning a prefix 69.0/24. Nice. Let's remind ourselves of what happens by default. R3 connects to R6 via a link with the IP address 10.10.36.0/24. This means that when R3 receives the 69.69.69.0/24, nice advertisement, and re-advertises it by IBGP to its best friends in network AS12345, R3 does not change the next hop. The next hop remains 10.10.36.6, the interface IP of router 6. Now this may or may not be a problem if all the routers in your AS know how to get to 10.10.36.6. It's all good. But some ISPs might consider the connection between R3 and R6 to be considered outside of their own AS, and as such the link won't be a part of their AS or ISI, or of their OSPF or ISIS, and it won't be redistributed in. This is where our famous next hop self command comes in. Before R3 advertises 69.69.69.0/24 nice into AS12345, it changes the next hop to itself, i.e. 3.3.3.3. Now all the routers in our AS know how to resolve the next hop. Plus, it means that we can use our RSVP LSP. R1 sees the next hop of 3.3.3.3 and sees that there's an entry in inet.3 for this BGP next hop, and then pushes the traffic down the label switch path. Imagine this scenario though. What if all the routers in AS12345 did know how to get to 10.10.36.6? What if we actually were redistributing this into OSPF or ISIS? In a way, our network would actually be simpler because we wouldn't have to remember to do the next hop self command anymore. But there's a downside. We're not running LDP or RSVP because between ourselves and this other internet provider whose AS number is 69, nice, this means that there's going to be no entry for 10.10.36.6 in our inet.3 table. In other words, this would be what happens. Router 1 looks up this prefix, sees a protocol next hop of 10.10.36.6, looks in inet.3 for this IP address, finds nothing, so falls back to the normal inet.0 table, resolves this IP in there instead, and sends the packet out as a normal unlabeled packet. This is probably the exact opposite of what you want to happen. Remember, for BGP traffic to go down an LSP, by default the BGP protocol next hop has to be in inet.0, and the interface IP address of R1's IBGP neighbor's eBGP router 10.10.36.6 certainly won't be in there. That is, unless we put it in there ourselves. Gosh, how naughty. Whatever will mother say, don't tell the police. The syntax is easy as pie. Just use the install command to associate the next hop IP with the LSP you've made. And that's under label switch path. Now 10.10.36.6/32 is in our inet.3 table, so any prefixes that we learned by BGP with a next hop of 10.10.36.6 will go down our LSP, or they'll go into the LSP tunnel, they'll go ingress. And hey, if you actually want traffic destined to 10.10.36.6/32 to go down the LSP as well, all you have to do is add the word active to the end of the install command. In other words, install 10.10.36.6/32 active. This will actually put the prefix in inet.0 with a next hop of the LSP. The prefix will no longer be in inet.3, but that's okay because Junos can use both inet.3 and inet.0 to resolve BGP next hops. It just prefers inet.3 if there's a tiebreak advantage. Gives you the most precision over what goes where. Disadvantage, this is basically a static route, so it's not very scalable. Override 2, advertise an RSVP LSP into your IGP. Okay, so this actually might be what I was looking at. Let's see. Nope, I don't see the keyword. But let's just keep reading this. I think I'm going to be able to finish reading it by the time the lunch hour is over. If we like, we can make OSPF or ISIS believe that our LSP is an actual link, directly connecting the two routers at either end. All you have to do is make LSPs in both directions, and then add the LSPs into your IGP with a metric of your choice. The syntax couldn't be simpler. Set protocol is ISIS, and then label switch path, the name of it, level 2 metric 1, or set protocols OSPF area 0 metric 1. You don't need the specified level because OSPF doesn't have levels, only ISIS does. That's it. Now you'll see the router at the other end of the LSP in your adjacencies. You'll see the LSP being used in SPF calculations. And we can see from our routing table that ISIS treats the LSP just like an available link. I gave this link a metric of 1, which gives us a total metric of 11. You can see that this is preferred over the non-labeled R1, R2, R3 path, which itself has a metric of 20. Advantage, gives you even more control over link cost than you had without it. Disadvantage, potential for inefficient paths. to be preferred over shorter paths depending on how the LSP is being formed. Override 3, move everything into inet.0. R1 has an LSP to R3. As we know, this means that traffic with a BGP next hop of 3.3.3.3 will go down the LSP. But what if you also want all network traffic destined to 3.3.3.3 itself to go down the LSP? Is there such a command to do that? Well, in fact, there's a few different ways, starting with this: set protocols, MPLS, traffic engineering, BGP-IGP. Perfect. This is exactly what this was going to be about. So this is the override option 3 to move everything into inet.0. This one command moves, not copies, but moves the contents of inet.3 into inet.0. LSPs will still be used to resolve BGP next hops. Remember, BGP can use both tables, it just prefers inet.3. But now all your other traffic gets to use the LSP as well. First, notice that our inet.3 table is now empty. Next, notice that everything is in inet.0 because RSVP and LDP have lower route preferences than ISIS. Our router is choosing these routes over our IGP. This is pretty cool stuff, and you might be wondering, if this is so cool, why isn't this the default? Why is it that only BGP traffic gets to use the LSP by default? A good question with a simple answer. Moving everything out of inet.3 breaks your ability to run MPLS VPNs. Don't worry though, there's a way to fix it. Keep reading. Advantage: only one command to give every non-VRF prefix access to the LSP. Disadvantage: breaks your ability to do MPLS VPNs. Please note, my grandfather taught me this command back in the year 1875. He made me promise on my life I'd never tell anyone. Well, we all know that promises only have a lifetime of 140 years, so now I'm prepared to tell you everything. So this almost seems like he's saying this is kind of a secret command, but that's surprising because it is called out explicitly on the test curriculum. Before I read this, I'm going to take a quick break. Okay, so I'm back. So override 4, copy everything from inet.3 to inet.0. This command does the same as the one above, but instead of moving the contents of inet.3 to inet.0, it copies it over. Set protocols, MPLS, traffic engineering, BGP-IGP-both-RIBS, RIBS. So yeah, this means that your normal prefixes can use the LSP, and also you can still run MPLS VPNs. If we do a lookup on router 1's routing tables for router 2's loopback, we see an LDP entry in both inet.0 and inet.3. Okay, so again you might be wondering, why isn't this the default? It seems like the best of both worlds. Well, as with all these situations, there's a downside. When you activate this command and you make an LSP the preferred route in your inet.0 table, this can seriously break your IGP. In short, your IGP routes are no longer the active route because now our LSP is the best route instead. And if our normal routes are no longer the best, this might stop them from being distributed properly. Luckily though, there's a fix for that too. So the advantage, it gives you loads of functionality, including MPLS VPNs. Disadvantage, can screw up your routing policies. Please note, my grandfather's grandfather told me about this command, and he made me swear to tell absolutely every person I met about it. Up till now, I disobeyed him because here's the twist. My grandfather's grandfather was Vlad the Impaler, the 15th century villain and archetypal router. No way was I honoring his requests, but I guess it's okay to tell you about it this one time. Okay, so I'm not sure what these notes mean, but it sounds like these are not really exactly meant to be used. So override 5, use the LSP just for forwarding and use your IGP just for advertising routes. What if I told you there was a command that copied LSPs into inet.0 for forwarding, but didn't use these LSPs when it came to making routing protocol decisions, and that this command also kept the IP in inet.3 as well for VP and use? Well, consider today a birthday and Christmas combined with this final command: set protocols MPLS traffic engineering MPLS-forwarding. So I'm surprised that's not in there, but maybe they wanted, yeah, maybe there's something where they want to remove this and replace it with MPLS.forwarding. This command allows your router to choose LSPs for forwarding traffic, but ignore them when it comes to the way the router advertises prefixes into your IGP. Take a look at this output and notice a few symbols in the legend, like the ampersand, the @ symbol and the pound signs. This shows us that traffic will be forwarded down the LSP, but ISIS still uses its own best path for consistent ISIS topology. Routing use only, forwarding use only. So yet again, you might be wondering, okay, this really does sound perfect. Why isn't this the default? Well, it sure is good, but the problem is that it's an all or nothing approach. This command copies everything into inet.0, which doesn't give you much control over precisely what goes in. If you do want everything to go in, great, but in an ISP-sized network, you probably don't. When you think of it like that, it's a little easier to see why this isn't the default behavior, no matter how romantically attractive it may seem. Advantage lets you copy inet.3 to inet.0 without it affecting your IGP's routing decision. Disadvantage doesn't give you much granularity on choosing exactly what traffic you should take your LSP. Please note, I am famous for being a traditionally handsome Hollywood hunk, which is especially impressive because he seems to be from the UK. So the fact that he's international crossover hunk, I think is more impressive. Okay, so I think this is going to be it for now. In the next video, we'll complete this, and yeah, it'll only take a few minutes. So we'll get on the lab and we'll try to get some hands-on experience with this just to drive it home. But hopefully that will be the final video. So stay tuned and thanks for watching.